We're going to be thinking about multiplication using partial products algorithm. So this algorithm helps us to break down a problem into multiple steps so that we're able to think about each step of how we get to the total sum or the total product of problem. So we're going to start out with thinking about 49 times 3. When we're thinking about 49 times 3, this 49 we can also think about as 40 plus 9 and break it down by place value. But even though we're breaking it down into two numbers instead of one, this 3, we still have to multiply that. So it'd be 40 times 3 and 9 times 3. So in partial products, we line them up as you see here, and then we have to multiply each number by that bottom factor, by that multiplier. So we have to do 3 times 9, and then 3 times 40, because this is in the tens place. So it's not a 4, it's a 40. So if we're thinking about 9, we can think back to our base 10 blocks to think about this visually. So we would have 9 ones. And then if we're doing it 9 times 3, we're going to have 3 groups of 9. So here we have our 3 groups, 1 group, 2 group, 3 group. So we can think about 9 plus 9 plus 9 is the same as 9 times 3, because it's that 3 groups of 9. So this would give us 27. So then we could write the sum of 9 times 3 up there. Then we'll move on to our next place value, which is our 4. In the tens place, it's 40. So if we had 40, which is 4 of our long base 10 blocks. So this is 1. We need it 3 times. Here's our second group. And then 1 more group. There's our third group. So we have 3 groups of 40. So we can think of 40 times 3 as 40 plus 40 plus 40 is the same as 40 times 3. So this would equal 120. We can go ahead and write 120 up here. Now, after we've multiplied our bottom number by each of the top ones, and we have those sums of those individuals, we have to add these up to get the total product of our problem. So 7 plus 0 is 7, 2 plus 2 is 4, 0 plus 1 is 1. Now we'll try this again without the base 10 blocks, so we won't have that same visual. So this time, we're going to use 27 times 32. So this is kind of the same, except this time on our bottom, on our multiplier, we also have something in the tens place. But we can still think about it in the same way, where our 27 is 20 plus 7, and our 32 we can think about in the same way. Our 32 is 30 plus 2. Now remember, our multiplier has to be multiplied by each of the numbers on the top. But our 30 and our 2, those aren't multiplied together, just like our 20 and our 7 aren't multiplied together. So for this, we can start with 2 times 7, which would be 14. So here we did 2 times 7. We could next do our 2 times 20, because we're still starting in that ones place. 2 times 20 is 40. Now we finished that, but we still have our 30 on our bottom factor that we haven't multiplied by anything yet. So now we'll move to our 30 times our 7, which gets us 210. And then lastly, our 30 by our 20, which gives us 600. So we can see in each of these, our 30 was multiplied by the 20 and the 7, and our 2 was multiplied by the 20 and the 7. Now, we have to take each of these and add them together for our total product. So 4 plus 0 plus 0 plus 0. 4 plus 1 plus 1 is 6. 6 plus 2 is 800. So our total product is 864. So the point of partial products is to break down each of our steps so you can visually see how it works. Instead of just going through the process, we're visually thinking about each step. So our step 1, like here, is taking our ones place in our multiplier, multiplying it by our ones place up here, or tens place up here. If we had a hundreds place, we would multiply it by that. And then at the end, we just add them all together. So this is building a better understanding of how the math works, why it happens.